So now in this video, I want to talk about combining batteries. So first off, we're going to start with a single battery. This represents a 9-volt battery right there. We got a negative terminal and a positive terminal. You put a load between them, you'll get about 9 volts across them, and it will be able to power that load for however long the load needs a certain amount of current, and the battery can provide that amount of current. As it discharges, the voltage is going to go down. So that's the basics of the battery. If you need a higher voltage, what you can do is put the batteries in series. So they should be about the same charge, but if they aren't, not end of the world either. But ideally, they should be charged the same and at about the same voltage. So 9 volts right there. When the battery's pretty fresh, both of them, then we will have about 18 out. So you can see that current has to flow through both batteries. Both batteries are pushing that current, when you got a load, and when there's no load, no current's flowing. But when you got a load, both batteries are pushing that current, and therefore their voltages add up. Pretty straightforward. Now, however much current you are drawing, that will be how fast the two batteries will discharge. So they'll both discharge as that current flows. And so the same amount of current that can flow through one battery, in this case, flows through the other battery. They discharge at the same time. They're both pushing that current though, so they have a higher voltage. Hopefully that makes sense. Adding more batteries doesn't give you more current, it's just a higher voltage. So the load may need less current because of that higher voltage, but the amount of current that actually flows stays the same as long as they're equally charged and everything. Now, you put batteries in parallel, and you got to make sure they're the same voltage when you put them in parallel, or the one with the higher voltage, let's say that one's higher, will charge the one with the lower voltage. And also, it's basically a short circuit if they have a big voltage difference. And so that may fry the wires or something, or be hard on the batteries. And so you want to charge them to the same voltage. If you're using lithium batteries, especially lithium iron phosphate, you want to charge both batteries completely and then put them in parallel. But in any case, we're going to look at 9 volts right there. The voltages don't add up at all. You get whatever voltage the two batteries are, each one of them will be the output voltage. And when they're in parallel, they'll have the equal voltage, unless one was higher than the other right when you connected them. But they'll quickly equalize. So, in any case, you got the same voltage as either battery, one of the batteries, but half of the current, as long as they're equal value batteries, half the current will come from one battery, while the other half comes from the other battery. So, whatever current the load needs. Compared to one battery, you'll be able to power that load twice as long, because one battery is only providing half the current at that point. And so, each one of them is going to be able to last twice as long as one of them alone. Hopefully that makes sense. Now, there's another thing you can do with a couple batteries right here, and it's just 2 batteries in series, but now we're using this node right there, that electrical connection point. And we just decide this is going to be our middle ground voltage. And in relationship to here, we may have some circuitry that comes from the positive supply over there, and then we may have some circuitry from the negative side of this battery connected, load over here. So that you can either be the source of the current at the output, or you can sink current at the output. You can do either. So it's important. Make sure you don't short, though, any of these 2 points together. You always need a load between the positive side and the negative side, and ground right there. And then if you could also have 18 volts across here. That's what a dual or a split supply means. And you can just buy power supplies that do that, but you can also take batteries if you really need one. And you probably won't need one, but if you do, you can do that. It's a cool circuit fragment. So now we looked at batteries in series, and we looked at batteries in parallel. So of course you can do series parallel connections. And so in this case, we'll have 18 volts. These 2 batteries are in series. Those 2 batteries are in series. And then both sets of batteries right there are in parallel. They're next to each other. And so we got the 18 volts out right there. But let's say we need to power something longer than when we had the 18 volts over here. We need to power it for twice as long. We can just simply take 4 batteries right there. And so they're in series for double the voltage of one of them, and there's 2 sets of them in parallel, so they can provide current for twice as long at a set amount of current as just one of those pairs. So you can just keep adding series and parallels until you get the values you want, the voltage you want, and how long you can provide a current on a full charge. And then again, you could also make a split supply with that. You need a split supply for whatever reason. You got ground, 9 volt positive in relationship to ground, 9 volt negative in relation to ground, but you need it to last longer. Then you can just, keep adding those series batteries in parallel as long as you need until you get the values that you want, the amount of stored charge. Make sure all the batteries are equally charged when you connect them, especially lithium iron phosphate. Fully charge every battery before you connect them. Now, 9 volt batteries, let's talk about the alkaline batteries. That's the one I can remember off the top of my head. Alkaline cells are about 1.5 volts when they are fully charged. So this is 9 volts. That's 6 times the voltage. It's inside the battery right there. You just have 6 cells that are connected in series like this. So there's 6 of them, 1.5 volts for a total of 9 volts. But in any case, that is the basics for how batteries work. Now the ways that you connect them, it's depending on what type of batteries you got and everything. There's a bunch of different ways to connect them. So you got to face that when you come to it. But the first thing you need to learn is you got a single cell or a single battery. You can connect them in series for higher voltage. You can connect them in parallel so that they last longer. You got more stored charge called amp hours or milliamp hours, also known as the capacity of the circuit here. And then, you can take it a step further. You need a higher voltage and you need it to last a long time. You can put them in series till you get that voltage and in parallel until it stores as much charge as you need stored. So, in any case, gonna end it there. Hopefully you enjoyed. Make sure you check out one of the other videos I posted on the screen and check out links down below. They all help a lot. I'll see you in the next video.